Okay, this is the second part of properties with exponents. And what we're doing here with the second part of these properties is looking at some division, some unique cases with negative exponents, different things you might come across. And really what I'm trying to do is give you a set of tools to work with so you can answer any problem dealing with exponents. So first thing we want to take a look at here should be pretty straightforward with these if you understood what we did before. So we have 3/5 3 times is really all that it means, right? 3/5 3 times, which means if you look up top, we have 3 powers of 3 up top and 3 powers of 5 down below. Pretty straightforward. And again, if you did the other, watch the part 1 for this, this should be pretty straightforward. So pause the video, take a minute, see what you come up with for the next 3. All right, so hopefully you took a time to pause this before these answers popped up here. If you take a look, c squared over s over 5 squared, 4 to the 5th over n to the 5th. This power distributes both to the top and the bottom, and it's for the same reason that you see here. We have 3/5, 3/5, 3/5. So that power will distribute to both the top and the bottom. This one I wrote out for you, c squared, c squared, c squared, divided by n, it gives you this. Now, one of the things you will see quite often, take a look here, see where it says n cannot equal 0. The reason they're putting this in there is because you cannot divide by 0. It's not really part of what you have to calculate in the problem. It's just an understanding that this right here in the denominator, you cannot divide by 0, so they have to indicate this for the problem. So the pattern you notice, I'll let you put this in your words, but you can do this part. Make sure you understand you cannot divide by 0. Which is the reason why this part's included, is just to remind you you can't divide by 0. And these, put in your own words. Do me a favor and take the time to put those in your own words. Now, we're talking about quotients of powers. We're talking about division. So when we're dividing, and I'm going to do this problem first, this one right here, because it's a little bit shorter, but I have 6 3s up top, and I have 2 on the bottom. And what happens is this and this can cancel, this and this can cancel, and I'm left with 4 powers of 3 up top. That's it. Now, the other way you can do it is just take a look at 6 minus 2 gives you 4. So this one again here, you can look at powers of 10 or powers of 2. And I have 10 of them. And then 3 of these, cancel, 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 and I have 7 left over. That's a good visualize to understand it. And, you know, kind of a shortcut is you can subtract these exponents. So here would be 10 to the 6th. This, what number when you take away 5 would give you 7? Well, that's going to be 2 to the 12th. Here, can you give me any 2 numbers that give me a 2? So it could be, you know, 7 to the 5th over 7 to the 3. Or you could do 7 to the 10 over 7 to the 8, as long as they're 2 apart. This one right here works as well as a b squared. So what patterns you notice is you could subtract exponents. And what mistakes do you think people make? One of the biggest mistakes that I see people make constantly is they're trying to cancel too much. Don't get in the habit, if you have something like 2 to the 5th over 2 to the 4th, don't get in the habit of canceling out these. It's just a bad habit to have. You're looking at the powers. And again, if you could just go back and remember that this is 2, 2, 2, 2, 2, and this, 4 powers of 2 on the bottom, I'm left with 1 power of 2 up top, or just a 2. So keep that in mind. Don't cancel out the 2's here. Just write out the powers. If you have that in mind, you really can't go wrong. Now, the last piece I'm going to do is this with exponents. What I'd like you to do is grab a calculator and look at this pattern here and see if you can fill out the rest of this pattern before I do. And there you go. You'll notice here, 16, 8, 4. All I'm doing is dividing by 2 to go in this direction. Dividing by 2, dividing by 2. And then you notice when I divide by 2, I get 1/2, 1/4, 1/8. And what you should see here is this 4, 8, 16, 32 looks very similar to this. This 2, 4, 8, 16. The reason why is these negative exponents. So you can look at 2 to the negative 1 as the same thing as 1 over 2 to the positive 1 down here. If you have 2 to the negative 2, it's the same thing as 1 over 2 to the 2. So a negative exponent in the numerator is positive in the denominator. And I'm going to pause the video and I'll let you see if you can fill this out as well. So take a minute to fill it out. And there you go. So what you should be seeing is this pattern again. 5 to the 4th is 625. This is 125 divided by 5, divided by 5, divided by 5, divided by 5. Keeps getting smaller. And these denominators over here, the 5, 25, 125, 625, those denominators are just the same as you see here. So again, a negative exponent, you can move to the bottom. So how would you describe what happens? One of the things I like to do is just do this, look at this visually, which is 2 to the negative 3 is the same thing as 1 over 2 to the third. Now, the same thing would actually hold true if you have a negative in the bottom. So let's say we have a negative in the denominator. So 1 over 3 to the negative 2. We can actually move this up and just make this 3 to the 2. Okay. You can also look at this if it helps to put it over 1. You don't need to. That 1's implied. But if you take a look, that's what the negative exponent would look like. So another way to write x to the negative 5 would just be 1 over x to the 5th. The other thing you notice here is if you keep dividing and eventually you get to the 0 power, it's because you're dividing 2 by 2 to get 1, 5 by 5 to get 1, whatever. So anything to the power of 0 is always going to equal 1. And I'm going to let you fill in some common errors here with negative integers, but if you just want to take a look to rewrite these following here. So this is just going to be 1 over 5 to the third, 1 over 2 to the fourth. And this one here, you have 1 to the negative 3 and 2 to the negative 3, right? Because if we put parentheses around here and we think about this, right? So we clean it up. This moves up top and this moves on the bottom. So you're left with 2 to the 3 and 1 to the 3. So hopefully this helps. Let me know if you have any questions, but good luck.